Today's about family of functions, absolute value functions from the graph, your new graphing parabolas. But here's what we're really doing today is we're going to talk about shifts and transformations. Shifts and transformations. And we're going to do things a little bit differently with our notes. We're going to do a little bit by hand, but then you guys are going to grab your Chromebooks, and you're going to be doing a lot of graphing. But instead of making you make a table of values and plot points and do a graph that way, you're going to be doing almost all your graphing on a Chromebook and just copying that graph in your notes. Okay, and I'll talk specifically about what I want you to look for, but believe me, it's a lot easier to do it on the Chromebook and do the graphing there and have it do the work for you, do all the heavy lifting, and you just have to write down the results. Okay, and it goes a lot faster and it's a lot easier that way. You will also have a worksheet today that will be due on Thursday when you come back. Okay, and you can use the computer to help you with the worksheet too. Okay, parent functions. Parent functions are the most basic type of function of an equation. Okay, y equals x squared is the parent function for all quadratics. It is the simplest quadratic, the absolute simplest quadratic. Y equals the absolute value of x. That is the simplest absolute value. That's why it's called the parent function. For linear equations, y equals x is the parent function. Any other function you have is changes to that parent function. Okay? Transformations are changes of parent function. What does a transformation do? Specifically, what are we doing to a graph? Now, there are several types of transformations. These are all transformations here. A translation is where the parent function shifts left or right or up or down. And what you do to that parent function determines whether it shifts left or right or up or down and which direction and how much. That's something you're going to have to figure out today as part of doing your notes. Okay? A stretch or a compression basically makes it skinny or fat. A stretch makes it skinnier, a compression makes it wider. Because you have your normal parabola, are you going to make it a wider parabola or are you going to make it a skinnier parabola? What changes to the parent function? What changes to this make that happen? Okay? This is probably one of the hardest ones to actually wrap your head around what's doing it. So you're going to really want to pay attention to what's going on there. A reflection, instead of pointing up, what makes it point down? That's it. That's what a reflection is. Normally, x squared and the absolute value. Ooh, that hurt. Sorry, my shoulder's still bugging me. So you have parabola, absolute value, straight lines. Okay. Normally they point up. Reflection, they're pointing down. Go straight. Just can't go straight while I'm up. Questions about this? Okay, so we are going to do a couple of by hand. Here's what I want you to do. Complete the table. Y equals x squared. Take your x, square them, plot the coordinates, sketch your graph through those points. Do the same thing for the absolute value. Take a minute, fill in the table. Because you got to know how to fill in the table of values. But you've done an awful lot of that. I'm sure that's not difficult. Okay? Plot the points, sketch the graph. So I've already filled in the tables. This shouldn't be that hard to fill in tables. Plotting the points. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and then 3, 9, negative 3, 9. And a parabola's got a curve to it. Absolute value. Looks like that. I know it's a little off, but the marker isn't lining up exactly where I want to graph on this one. But that's what that looks like. These are your parent functions. Everything you're going to do today is going to change those. You're going to add or subtract to x squared. You're going to multiply things times x squared. You're going to do the same stuff to the absolute value. You're going to add or subtract. That is going to change how that looks. It's going to move the whole thing up. It's going to move the whole thing down. It's going to make it go left or right. It's going to make it wider. It's going to make it narrower. It's going to make it point down. Your job today is to figure out what changes to the equation make what changes to the graph. Okay. Now, if you turn the page in your notes or the next section of the notes, I've already given you hints. Okay. I've already given you hints. So these are the parent functions with other stuff thrown in there. This is extremely typical of what we do. Think of mx plus b. This is the same setup as mx plus b for a linear equation, only you don't have m because you don't have a slope. We don't do b for the y-intercept. We do other changes. Okay, m and b are the changes we do to change a straight line. Change the slope, maybe have it go up or go down, move it up or down. Technically, that also moves it sideways as well, but we only worry about the up and down on the straight line. That's what the b does, it moves it up and down, and the slope makes it go. Basically, that does the stretch or makes it reflect through the line if it's negative. Okay, that's what these things do. So y equals a x minus h squared, and the minus h is inside the parentheses, plus k is on the outside of the parentheses, and the a is in front. The a does the stretch, compression, and reflect. If I change the value in front of the x squared, that changes whether it's skinnier or wider or points down or up. Your job today to figure out what values of a make it skinny, what values of a make it wide, what values of a make it point down. Okay? The h moves it left and right. What values make it move left, what values make it move right, and how far. And it's not intuitive. Okay? K, the vertical translation. K makes the whole thing move up or down. What values of K make it move up, what ones make it move down, and how far. You need to know this thing. The vertex of your parabola comes from the h and the k. The h and the k move it left and right. That will tell you where your new vertex is. Normally, oops, too far, sorry. Normally the vertex is on the origin. If I add or subtract, if I change what's inside and outside, it moves that origin. That's the up and down and the left and right. Moves the vertex off of the origin. And the same thing holds exactly the same for the absolute value. The only difference between the absolute value and the parabola as far as changes go, the only difference between the graphs, this is a U, this is a V. Those are the only differences. And your goal is to, by the end of today, and well before the test, which you will be taking next week on Thursday, is if I give the equation y equals 2x squared plus 3 minus 4, you can sketch that. Without making a table of values, you can give me a sketch of that. It would look something like that. And you will be able to hopefully do that. Look at this and know, okay, I move it, and it's taller, it's skinnier than what a standard one is. Okay. So here's what I want you to do. We'll pause it for a second. Okay, so if you look at the next page, your next set of notes, it says graph it. Now, it's got a table of values set up. You can do the table of values if you really want to. I firmly believe that you're quite capable of filling in a table of values appropriately and plotting the points and drawing the lines. I could make you do that, and I could make you do it over and over and over and over and over again. However, let's let technology be the tool that we can use in order to speed this up, because that's what using this the Chromebook is about, is to take the tedium out of it. Okay. So the first example problem 1, graph each equation. graph 4x squared and graph the absolute value 2x. So here's what you're going to do. Go to Desmos. And I'm going to do first. Now, this is nice because it makes it easy. You can pull this keypad up here yourself. Y equals, and I'm just going to do straight up x squared. I like to have the parent function on my graph before I add what the changes are. So this is my parent function. This is what that first graph looks like. Open up a second graph, and it's y equals 4x squared. 4x squared. So the red one was the parent function. The blue graph on mine anyways is your new one. What does the 4x do? Makes it skinnier. It doesn't move it left or right, but the 4 in front makes it skinnier. In your notes, 4x squared makes it skinnier. Okay. So does that make sense? That's what I want you to do. I want you to graph that on there. Okay. Now, if you want to graph the parent function on there too, and maybe make a note. Might be a good idea. Skinny. So, what's your prediction that the 2 is going to do to the absolute value of x? So I go back to, there we go. Go back to here. I'm going to get rid of that one, get rid of this one, and I'm going to go, okay, y equals absolute value. Notice when you type in the absolute value, it's the absolute value key, and you do have to use the absolute value key. It gives you one bar. You type in what you want. There's the absolute value. If you want to get past the bar, you got to type past it, and it'll move you past the absolute value key. Because it's automatic parentheses where it gives you both of them, and you fill in what you want until you move the cursor to the outside of it. Okay, so there's the basic absolute value. Then I have y equals, and my function was 2 times the absolute value. What do you think the 2 is going to do? 2 absolute value of x. What did it do? It made it skinnier as well. Did not make it as skinny as 4 did to the parabola, but it did make it skinny as well. Okay. So putting that in makes it skinnier. Skinny wide, skinny wide, skinny wide. That's what I want you to notice, those things, so we can make a prediction. So that tells me, what does the 2 here do? That 2 makes my parabola skinny. So that was one of the things I wanted to know. You're going to need to know, what does that do? You're going to need to figure out, what does that do? Okay? So I have this. I go back to my notes. And I sketch in my new absolute value. Notice I did not break out a ruler and, okay, it's perfect. This is exactly where I want it to go. I don't want exactness. If I want exactness, I use this. I use a computer. The only thing you can draw with real exactness is a straight line, and even then, you're limited to the quality of the tools you have when you draw it by hand, and you're never going to be perfect doing it by hand. I don't want perfection. I want a good idea of what it's supposed to look like. Okay, I don't want perfection. I want a good idea of what it's supposed to look like. Now, when I do your quizzes and tests, the thing I'm going to be looking for, is my vertex in the right spot. Are the coordinates, and you won't have to give me the coordinates, but you're going to have to plot the coordinates, plot the vertex. I'm going to be looking, is that in the right place or not when I grade your test and your quiz? Is it skinny or wide or basically normal? And it doesn't have to be exactly the perfect amount of skinniness or the exact amount of wideness, but it has to be a little bit wider. It has to be wider than normal, or obviously skinnier than normal. That's what I'll be looking for. And does it point up or down properly? That's the other thing I'm looking for. Okay? So I want to be clear on that. The other portion, and we'll talk about this when you see the practice test, is that you will have to identify in words, what does this -4 do? In words, what does, and actually my square on that one's in the wrong place. Square should be here, my bad, I just realized that. What does this +3 do? What does this 2 do? You'll have to be able to tell me in words or identify in words what those things are as part of your, I'm not sure on the lesson quiz off the top of my head, but I know on the test that will be part of what's going on with the test. Okay? Any questions? So it's up to you